The first part that we want to talk about in Module 2 is probability. So what is probability? Probability is the quantification of uncertainty, or placing a number on how certain or uncertain we are. So think of it like checking the weather, right? We wake up in the morning, we go, what's the high supposed to be? There's a certain probability with that, right? Might go above, may go below. We're not completely sure, but we're within the realm of certainty that it'll be around there. So there are some rules when we talk about probability. The first one is the probability of an event is going to be expressed as P, and then you place the event name in the parentheses. So if you were wondering, what's the probability that I'm going to have a girl? You would write P, girl, since having a girl is the name of the event. So any event that you're looking into, maybe pulling a card, pulling an ace, rolling a die, rolling a 5 on the die, that would all go inside of that parentheses. Okay, the second rule is that all probability has to be between 0 and 1. Essentially because it has to be from 0, which is impossible, can't happen, and 1, which would be 100% possibility that it's going to happen, which means we are absolutely sure that it is going to happen. For example, the probability of you having an assignment next week is 1 or 100% because we are certain you're going to have an assignment next week. Okay, and then you can kind of see like it's a scale. So 0.5 would be in the middle, so 50-50 chance of tossing a head or a tail. Rolling a 1 on a die would be 0.167, or if we were to change that to percentages, we move the decimal over 2, which would give us 16.7%. So not very likely to roll a 1 on a die. Versus very likely would be towards the 1. So it's just like a number scale between 0 and 1. So you're always going to end up with a decimal, and then we can convert it to percentages. And I'll show some examples on how to do that as well. So how do we calculate what the probability is? Well, the probability of something happening is the number of successful outcomes, or the number of ways that event can occur. So number of ways event can occur over the total number of outcomes, or the total number of possibilities in that experiment. So let's walk through some examples, because the best way to understand probability, since there's so many different examples that you could use, it's just a practice. So let's look at rolling one 6-sided die. So think of a 6-sided die, there's one, okay? Think of all the possible outcomes. So this comes from last week when we talked about outcomes. You could have 1, 2, 3, 4, 5, or 6, right? You could have any of those outcomes when you roll this die. So what probability do we want to find? The first one is the probability of rolling a 5. So we start off with our format, P parenthesis, name of the event, which is rolling a 5. You can loosely describe your event inside those parentheses. It doesn't have to be specific. So the probability of rolling a 5, the top number is the number of ways to get that event. So how many ways can we roll a 5? Well, there's only one. There's only one way to roll a 5. So we would write 1 on top. The number on bottom is the total number of outcomes. So we look at how many different outcomes there are. There's a total of 6. So it would be 1 out of 6. On your calculator, you're going to go ahead and grab it, and you're just going to type 1 divided by 6. It's always top divided by bottom. So you can see here 1 divided by 6. Hit enter. we get 0.1666666, so on and so forth. I like to round it to 3 decimal places. So that would be 0.167. And the reason that I rounded it up is if we look to the next spot, okay, because it's originally 0.16666, blah, 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 blah. So we want to round it to this place here, right? Well, the next number is a number that's larger than or equal to 5, which means we need to round this guy up. So you're always looking at the next spot to see if he rounds him up or not. Now, that comes with a little practice. Just keep trying and working through it. I won't take off points if you do misround things. Just try to stick to those 3 spots after the decimal. Then to change it to a percentage, we just take that decimal and move it 2 spots to the right. So this becomes 16.7%. So you have a 16.7% shot of rolling a 5. So if you only have 1 die left in Yahtzee, not that high of a probability to roll a 5. Let's look at rolling an odd number. So again, we start off with probability of rolling an odd. The number on top is the number of ways to get that event. So how many odd numbers do we have in our outcomes? We have 1, 2, 3 odd numbers. And then what number goes on the bottom? It's the number of the total number of outcomes, which would be 6. And again, we can just take our calculator, plug it in. 3 divided by 6, 3 divided by 6, hit enter, you get 0.5. Now we need to change that to a percentage. So we take that decimal and we move it 2 spots to the right. Now notice there's this empty spot. We can go ahead and fill that in with a 0. So this becomes 50%. So there's a 50% chance that you will roll an odd number. And that makes sense because half of the numbers are odd. Okay, let's look at rolling a number less than 3. Less than 3. So probability of rolling a number that's less than 3. So how many numbers are less than 3? Be very careful because less than does not include 3. So it's 1 and 2 are the only numbers that are less than. So there's only 2 possibilities of numbers that we can get out of a total of 6. So again, grab your calculator, type it in. 2 divided by 6 is 0.33333333333. Now we're going to round to the 3rd spot. Now since the 4th spot is a 3, it's a number less than 5, we can just drop it off. It doesn't round the number up to the next spot. It has to be a number greater than 5. So then we go ahead and do the same thing. We're just going to take that decimal, move it 2 spots to the right, and we get 33.3%. Okay, so those would be probability of rolling 1 die. And there's different events that you can talk about and work with, so be careful on reading these closely and paying attention to those keywords. It will make a difference. Speed is not your friend here. We don't want to speed through these, okay? So let's move to the next example. So congratulations, you have made it to Wheel of Fortune. You must spin the spinner to the right. We want to find the probability of the following events. So what is the probability of getting 200 points? On one spin, we should say. Okay, so we always start with the top number. top number is how many ways that event can occur. So how many ways can we roll a 200? So we're just going to go around here and circle. It looks like we have 1, 2, 3. Try to read these upside down. 4. I think that's all of them. So 4 different ways to get 200 points exactly. And then out of how many total possible spins? So I'm going to start at Bankrupt here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. So out of 24 possibilities. And I would encourage you to check that again, just to make sure. And then we can go ahead and divide these. 4 divided by 24 is 0.16. And then the next one would be 6, and the one after that would be 6. The 6 rounds it up to 7. And then again, just move that decimal 1, 2 spots to the right to get 16.7%. Okay. What's the probability of landing on the bankrupt tile? That's the tile you do not want, right? We do not want that tile. So how many different ways is there to get the bankrupt tile? Only one. There's only one tile that's bankrupt. Out of how many? 24. So again, 1 divided by 24 gets you 0.04166, so on and so forth. Now we need to round that to the third spot. So should I round that up or not? Well, since the next number is a number greater than 5, we're going to go ahead and round that up to 42. Then I'm just going to move that decimal 2 spots to the right to make it 4.2%. So it's really not a high probability that you're going to land on the bankrupt tile, but it's still a lingering fear, right? Who knows, maybe they weight it differently and actually kind of cheat and put a little bit more weight on there, right? We don't want to think about that, but it's possible. Let's look at the probability of landing on anything besides the bankrupt or lose a turn tile. So anything but bankrupt or lose a turn. I'm going to abbreviate that just because we're running out of space. So I'm going to go ahead and erase this real quick just to make it out of our way. Okay, so how many tiles are there that are not bankrupt or lose a turn? Well, I know that there are 24 total tiles, and there's one tile that's bankrupt and one tile that's lose a turn. I don't want those two. So there's only 2 that I don't want. Okay, so 24 minus 2 leaves me with 22 tiles that I do want. That would be anything besides bankrupt and lose a turn. And you can always go ahead and count all the tiles that weren't bankrupt or lose a turn. That would work as well. So 22 out of 24. The number on the bottom is always just that total number of options. So when I take 22 and I divide it by 24, I get 0.91666, keep going, which rounds to 0.91. Now this is the third spot after the decimal, so I want to check, do I need to round it up? I look to my 4th spot. Yes, I do. So I'm going to round that up to 7. So move that decimal 2 spots. It is a 91.7% chance that you are going to land on anything but bankrupt or lose a turn. So pretty good probability there. Make sure you are following along and trying these in your calculator to make sure you understand how to use your calculator. If you're running into big issues, feel free to reach out to me via email. I'm always here if you need anything. We have just a couple more examples, but now we want to look at a deck of cards. So I grew up playing cards. I love cards. They're so much fun. There's so many games that you can play with them. But just as a little review, there are 52 cards in a deck, and there are 4 suits, clubs, which are black, diamonds, which are red, hearts, which are also red, and then spades, which are black. Okay, so 2 suits are red and 2 suits are black. In each suit, there are 13 cards. Okay, 13 cards in each suit. You start with ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then when you get to 11, you actually turn into the face cards. These are the face cards. I just like to go over this because there's some people that aren't familiar with cards. So no big deal. Jack, Queen, and King are face cards. So notice for each type of card, so like a 10, there's 4 different 10s in the deck, 4 different 9s in the deck, so on and so forth, because there's 4 suits. Okay, let's go ahead and jump into calculating the probability then. So we'll start with drawing a jack. So the probability of getting a jack from the deck. Top number is always the number of ways to get that card. So how many jacks are there in the deck? Well, we just said that there are 4 jacks, 4 of each type of card. Okay, and then out of how many? 52. 52 total cards in the deck. So 4 divided by 52 is going to be 0.07, and then 6, 9. Since I want to round it to 3 spots, I need to round up since that's a number larger. So this would be 0.077, which gives me 7.7%. So not a high probability of just pulling a card and it being a jack, right? Not very high probability. How about drawing a club? How many clubs are there in the deck? Well, we talked about this. There are 13 cards of each suit. So in each suit, there's 13 cards, ace through king. Out of 52, go ahead and calculate that. 13 divided by 52 is going to be 0.25, which is 25%. Remember, you're just moving that decimal 2 spots to the right. Always 2, never more, never less. So, a 1 in 4 shot that you're going to get a club. How about drawing a queen or a heart? Now, this is a little trickier, okay? Now, we know that there are 4 queens in the deck, 4 queens, 1 of each suit. And there are 13 hearts in each, well, in the total suit, right? Okay, ace through king. But if we add this together, we're actually double counting a card. Which card are we double counting? The Queen of Hearts, because it's in both sets. So if I add these together, that's going to give us 17. But we need to subtract off one of those Queen of Hearts because we double count it, which would leave us with 16 total possibilities. And if you wanted to, you could list them all out, like Queen of Spades, boop, oh, trying to draw here and it's not working. Queen of Spades, Queen of Clubs. As you can see, I'm very talented at this. Queen of Diamonds, and then list all 13 hearts, including the Queen of Hearts in there. So This would be 3 plus 13 is 16. So you can look at it a couple different ways. That's the beauty of mathematics. You can come from it from a couple different point of views. Just because you're not looking at it the exact same way that I'm looking at it or your classmate is looking at it doesn't necessarily mean that it's wrong. It's just a different point of view. That's the beauty. And some of you may be like, that's the pain as well. Hopefully not. So 16 divided by 52 is 0.3076. So that 6 would round it up to 8. Oops. Of course, we want to change that to a percentage. Move that decimal over. 1, 2 gives you 30.8%. So pretty good probability that you're going to pull either a queen or a heart. Okay, this is our last example that I want to walk through. So you are taking a 3-question true or false quiz. Unfortunately, you did not study, so you're going to be guessing. Find the probability of the following events. So the first thing I'd like to do before I even jump into probability is to understand the event and the possible outcomes. So I want to write out the sample space. So before I even look at what probability I want to find, let's go ahead and write out the sample space. So it's a 3-question true or false quiz. So think of it: question 1, question 2, question 3. What are the possibilities? You'd be true, false, true, right? That would be one option. You could have all trues. We have true, false, true. Then we could rearrange that. It could be false, true, true. True, true, false. I'm looking at the options where there's only one false present. You could have 2 falses, right, and 1 true. Then we just rearrange that. Yeah, true, false, false. And then the last option would be if you just randomly guessed and said, hey, they're all false. Right? So how many total outcomes do we have in this sample space? We have 1, 2, 3, 4, 5, 6, 7, 8. And if you want to hear more about that sample space, go back in week 1. We talk about sample space and how to come up with that. So check that out. But let's jump into probability now. So we want to find the probability that exactly one question is true. Exactly one question is true. That exactly is very important. One question true. So we look at these different outcomes and we say which one has exactly one question true. Well, this has 3, this has 2, 2, 2. It says one question true, one question true, one question true. And that has 0. So there's only 1, 2, 3 outcomes out of 8. So 8 is the total number of outcomes. So let's go ahead and divide. 3 divided by 8 is 0.375. And we can always move that decimal 2 spots to the right to get 37.5%. Boom. So pretty good probability that exactly one question would be true. How about more than? More than one question is true. More than means greater than, not equal to. So just greater than one question true. So it has to be more than 1. So it could be 2 or 3 questions that are true. So how many of these possibilities, let me erase the ones we circled before. So out of all these outcomes, how many have greater than one question true? Well, this has 3 questions true. That's definitely greater than 1. This has 2. That's more than 1. Same thing, 2, 2 true. It says 1 true, which doesn't fall into that category, right? Because it has to be more than 1, not including 1. So it looks like we picked 1, 2, 3, 4 outcomes that fit this scenario out of 8 total outcomes. So let's divide that. 4 divided by 8 is 0.5. Again, move that decimal 1, 2, fill zeros into any open spots, so that would be 50%. And boom, pretty good probability that more than one question is true. What is the probability that you get all questions correct? So this one's kind of a tricky one, so it's just kind of a fun one to think about. But if you think about it, how many of these solutions are going to be the correct answer key? So how many answer keys does your professor have? One. Only one of these is the correct answer key. So there's only one way for you to get this correct out of 8. So if you were to randomly guess, what's the probability that you would be 100% correct? It would be 1 divided by 8, which is 0.125, which, move that decimal 2 spots, 12.5%. So you have about a 12.5% of getting 100% right just by guessing. That's pretty crazy, but it's only 3 questions. As they increase the questions, the probability starts to decrease, and especially if they do like 4 choice, multiple choice, that's going to decrease even more because there's many more outcomes that are possible. So it's harder to just randomly guess. Okay, so that was probability for you. Practice that on your own. Remember that the top number is always how many ways that can occur. So make sure you're understanding the outcomes before you move on to that probability. And then the bottom number is always the total number of outcomes. So try that out. If you have questions on the calculator or the sample spaces, feel free to reach out to me and I'm happy to help.